Okay, hi guys. So in this lecture, we'll be continuing on seeing some more concentration terms before jumping on to seeing problems on the same. So next concentration term is ppm. Okay, so it is also known as, or it's a abbreviation for parts per million. Okay, so example of this is we have, let's say, 10 ppm of K plus present in seawater. Okay, therefore it is equivalent in saying that we have 10 raised to the power 6 grams of seawater contains 10 grams of potassium. Okay, and concentration of solute in ppm is actually can be said as concentration of solute in ppm can be written as weight of solute upon weight of solution into 100, or not 100, times power 6. Okay, and you can also say that in a very dilute solution we can have that weight of solution equals weight of solvent. Okay, for gases we can say that mole percent equals volume percent. Okay, at constant temperature pressure V is directly proportional to N. Okay, therefore we can say that V1 upon N1 equals V2 upon N2. Okay, so example is that air sample contains 40 ppm SO2, therefore 10 raised to the power 6 volume of air contains 40 volume of SO2 gas. Okay, so we can say that concentration of gas in a gaseous mixture would be equal to volume of gas upon volume of mixture into 10 raised to the power 6 in ppm. Okay, so one more important concept here is the concept of ppb. ppb is nothing but parts per billion. Okay, so in that we can say that ppb is equals to weight of solute upon weight of solution into 10 raised to the power 6. Oh, sorry, 10 raised to the power 9. 10 raised to the power 6 was ppm. Okay, so next we can say that we can also say that parts per billion is equals to weight of solute upon weight of solution into 10 raised to the power 2 into 10 raised to the power 7. So this is equal to weight ppb equals to weight percent of solute into 10 raised to the power 7. Similarly, we have ppm as weight of solute upon weight of solution into 10 raised to power 6. It can be written as weight percent of solute into 10 raised to power 4. So next question comes as we have 8% of W by W NaOH aqueous solution, which would be 100 grams NaOH aqueous, rather 100 gram of water contains 8 grams of NaOH. Okay, so now let's say we want to convert percentage W by W into percentage W by V. Okay, so volume can be calculated of water as mass upon density of water. Okay, mass is already given 100. Let's assume density of water is D. Hence we can say that percentage W by V of NaOH aqueous would be, what is the mass of NaOH? 8, and what is the density? It would be 100D into 100. Percentage we are calculating, so it would be 8D. Okay, so next question is you have to convert 5% W by W CH3 OH aqueous solution into percentage small v over v. You have been given that density D1 as the density of solute and D2 as density of solution. Okay, so next we can have the solution as you have been given that 100 grams of water contains, or solution contains, rather let me write it as solution only to avoid any confusion, of solution contains 5 grams of CH3OH. Okay, what would be the volume of 100 grams of solution? Volume is equals to mass upon density. Okay, using the same formula we can apply that 100 upon this, or rather I can say that percentage V by V, small v by V, would be mass of solute upon density of solute, which is D1, upon mass of solvent, not solvent, solution, upon density of solution, which is D2. This would into 100 would be our answer of percentage V by V. So this comes out to be M of solute is 5, density of solute is D1, upon mass of solution is 100, it is multiplied by 100 divided by D2. 100 and 100 get cancelled, so finally percentage small v by capital V would be 5D2 over D1. So this would be the answer. Okay, and next, if we have been given that D2 is the density of the solvent and not solution, then how do we do this type of problem? Then you have been given that the solution contains 5 grams of solute plus 95 grams of solvent. Okay, now what would be the volume of solute, volume of solute would be mass of solute divided by density of solute. Okay, and what would be the volume of solvent? Volume of solvent would be mass of solvent upon volume or density of solvent, which is d2. Okay, then what would be V, or rather capital V of solution? So capital V of solution would be small v of solute plus small v of solvent, or rather volume of solute plus volume of solvent. This is 5 over d1 plus 95 over d2. Okay, then percentage small v by capital V would be 5 upon d1 is the volume of solute, and volume of solvent is 5 over d1 plus 95 over d2 multiplied by 100. This would be the answer. You can simplify it and reduce it via taking LCM of denominators and do all type of mathematical operations, but core would be this thing. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the concentration terms.